Hey guys, welcome back to a new video. And in today's video, I was thinking we are going back to numpy, right? So in the last video we worked on this little project here which takes a input from you, asks for like dataset size, and you take the dataset size, and then you generate a histogram and a box plot. So I did say in that video that we could go ahead and work on this project even more, maybe like expand on it and do that. So yeah, so to start off with, this was our old project. As you can see, it's very nice. Just gonna fix up this, just like tidy up a bit, there. Also change my keyboard settings because I think, yeah, nice. So run this. Let's open the console, enter data size. Let's input a random number that comes to mind, which is like 64. Then it gives you the median and the standard deviation, which we have set to 1. I guess is I think it calculates it instead, but as you guys can see in the output, it gives us two plots, which is the box plot and the histogram. Now, I don't think I can zoom out to anything really. Oh wait, I can. Okay, whatever that did. Okay, now I think I clicked this, but as you can see, this is our plots, and yeah, let me just open up console back. So, let's get started with the news. So, to start off with the new part, let's go ahead and open up the home. Go click on create REPL. Now I have mine zoomed in because Replit usually is like very like how do I say this? It's like it's just like small, everything's small. So like I just like it bigger because it's very easier to way easier to read, and you don't have to strain so much. Yeah, so that's just me. I pretty sure I keep it on 175%. So yeah, the name for the template, Python data science. Replit has actually, instead of making one Python for everything, they split everything up. So they have Python data science, they have Python this, that, whatever, literally everything. But this one contains NumPy, Pandas, Matplotlib, TensorFlow, and more. So let's name this NumPy 2. All right. So basically, it's gonna be the same as the first NumPy, just that what's gonna be different now is that we're gonna add more to it, and we're going to also, add new functions that will, you know, also help us and also make the code like more advanced, I guess, if I could say that in a way. But yeah, let's get started. So import numpy, and I'm gonna keep that as np. Then you're gonna do import matplotlib dot pyplot as plt. Now, if you do think, why is it showing up gray? Why is this gray? This gray just means really that it's imported but not used. Now let's go down over here and create the first function, which is going to be the generate the random data, right? So for this, let's add a few things. Now, before we add the size, now here we're also like, we're also specifying what kind of data type it is. So the size is, oops, so the size is integer, of course. The mean is a the mean is a float, and this equals to 0. Then the standard deviation, then take this float equals to 1. Next, let's you create this arrow, and then you do np.d array, nd arrow, sorry, nd arrow, not p array, what am I saying? But yeah, so this is for basically generating the random data from a normal, the from generating the random data from the normal distribution, and the standard deviation, right? So let's just go ahead and continue. Uh, Define a new variable called data np dot random dot normal. This is exactly like we did in the last project, and just create the scale for it. Standard deviation, size equals to size, and then just return data. Next, we're going to define the compute statistics function. Add the data and then the np.ndrarray there, nd there, and then we just do the same thing we did here. How did I get, oops, there. But for this one we're gonna add a tuple and float, and then continue on. Now for this one we're gonna add the mean, the mean np.mean, and then on the data. So we're storing the mean. We're using np.mean on the np.mean function on the data and storing it inside the mean. So we're also gonna do this for the median. So median equals to np.median, and then on the data, standard deviation equals to np dot and then standard deviation, the function for that on the data. And then also for the sample of the standard deviation, we're also going to keep the DDOF equal to 1. Next, return all of these, so median and standard deviation. Now, what this is going to do is going to compute the mean, median, and sample the standard deviation of the data, right? So, moving on, we're going to make the next function, which is going to be the plot, right? So, define plot. And for this one, add the data and then just same thing, np.nd array, which is the main object here. We always need to add that. Now for this next one, we also have to specify that none. And I don't think this goes here, this goes here, this goes here, and this goes here. Right, so nice. Now that this is done, we can create the figure, sorry, no space, figure, and the fig size. Now this is going to be the same as last time. We're just going to use 12 to 6. And continuing, let's create the subplot. Now here we're going to make the um, labels and the stuff. So let's create the subplot first. 1 2 sorry 1 2 comma 1, and then create histogram plt.hist data bins, and then specify the number as bins. So let's actually add 40 bins this time. Color equals to blue, and the edge color, let's keep that to black. Next, add the titles. So the title for the histogram is going to be histogram. You can name it whatever you want. You can also name it what the value is. Sorry, not value. What am I saying? Plt.x label. That's what I need to do. Now the x label is going to be the value, and the y label is going to be showcasing the frequency. So let's name them accordingly and move on to the next subplot, which is going to be the box plot. So 1 2 2, keep that there, and plt.boxplot on the data, and vertices false, vertices no, vert equals to false. Plt.title, name title, so the box plot is going to be named or called or have a title just called box plot, and then add the x label, which is going to show us the value, and then just repeat the same things we did last time. Type layout and plt.show. Now next is the main function. So we're gonna make the main function. For this one, keep this to none there. And now what we're gonna do is we're gonna for the main function is going to be like plotting our results, right? And it's gonna be generating the data. So also, when we ask, like, for say, like what I tested in the last numpy is that when we like entered the data values, the no, for like the entered the data set size, you could add in anything else and it just give an error instead of like you explaining there. So like let's say the user has absolutely no idea what they're doing, they're just doing what it says, and just a bunch of random text shows up, you don't understand what's going on. And to avoid this, I want to add like this error function. Will basically raise a value error, and then show that. So while true, we're gonna use this loop, and to find hold on, yes, while true, and to find errors we use try. So set the size equals to, and then integer input. Now here we take the size from the user, dataset size. Now if size is less than equal to 0, we're going to check that. We're going to raise a value error and say that the size must be a positive integer. Now then break, and then accept value, oopsies. This accept should be breaking or like coming down here. Then accept value error. Sorry, didn't even type that in. Value error as E. So now our value error is E, and then we're just gonna say print F invalid input, and here we're gonna show the invalid input, or no, the error, and then we're gonna say please try again. Hmm. Now, okay, let's move everything accordingly. I think it might actually work without having to move all of this up and down. So, what does this say? Unexpected indentation, Y. Oh, no. But we're trying this inside the voucher. No, 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 no. So, keep this like this. And the accept shouldn't be breaking the while true, but it should be breaking the try. Next, moving on, breaking the while true, we're gonna add the data equals to generate random data. We're gonna add this function on the. We're gonna use this function or apply this function on the size variable, the mean, median, and standard deviation equals to compute statistics, and then on the data. Next, we're gonna Next we're gonna print our results. So print F, and we're gonna say mean, put this, and then add the mean, right? So the mean, then you can just copy paste this down. This is gonna be the median. This is gonna be the standard deviation, and then create a standard deviation. Now we're just gonna plot the data after that is done, and if underscore name underscore equals to underscore main underscore create the main loop here. So main done. Now I might think that this might give an error, and it will. So let's try and fix this. Statements must be separated by new lines. What? New lines are semicolons. What does that mean? Hello. Well, true. Why is it saying that? Come on. Okay, let's put this all into modify with AI. Fix it. Oh, wait, no way. Actually, okay. So, no, wait. While true, the lowercase w, and run this, should give us the, okay. Now enter the dataset size, 76. Oh, line number, line number 51. Whoa there. Did you mean false? Where did I write that? Oh, okay, guys. So debugging is very important, and make sure to triple check your code and don't be like me. Okay, so we have our standard deviation, we have everything else, and we also have our um, plots. That is cool. So yeah, nice. Now let's try out the error, like the error, to check if it can notice difference. So yeah, invalid output. Yeah, so invalid input. Sorry. So please try again. Enter dataset size. Let's add this -3. Invalid input. Size must be a positive integer. Please try again. Okay, nice. So it does add a period at the end, so we don't have to add that. -3 again. Okay, never mind. It does. Okay, whatever. Yeah. So it works, and it actually turned out very nicely. And yeah, so that's about it for NumPy 2, and see you guys in the next video.